Let's talk about how we improve program performance with this ceremony that we call Inspect and Adapt. What is Inspect and Adapt? Well, it actually is a ceremony that consists of three parts. The first part is the PI system demo. This is where we demo the system that we've demoed before, except this is kind of unique because this is an accumulation of everything that's happened during that period. It's not just, hey, there's a new feature, there's actually quite an accumulation of new features. So it's a big event. And for certain stakeholders, this is kind of the only time that they can realistically attend. You know who they are. The head of the data center, the VP of development, maybe the VP of product management. They're not able to necessarily participate in these system demos. We want them to, we invite them to, but can I necessarily bring an outside customer in? No. So the PI system demo is a key part of that. We'll talk about that a little bit more. We'll take our quantitative measures here too. I think we all have a love-hate relationship with measurements. The things you want to measure are really hard to measure, and when you measure the other things, you end up, changing behaviors in a way that you didn't anticipate. But we have a lot of quantitative data that we can collect, and I'll show you some examples of that other teams have used and other programs have used to good effect. And lastly, the problem-solving workshop, which is the deep part. That's a heavy lifting part where we run a big retro and really get to the root of the problems that are interfering, not with just team performance, but with overall program performance. Attendees, teams and stakeholders, everyone when you can, and that's why you saw us lay out the IP sprint with time for that, because the problems that the teams can solve, they will tend to solve. They have a model to do that. They know how to run their retro and they can improve their stuff. Can they improve stuff outside of their control? Well, we know the answer to that is not necessarily. And we know how frustrating it is for teams to try to get better and better, but our other folks aren't there or aren't participating or don't recognize that indeed they're part of the problem or a part of the solution, and we want them to be part of the solution. Time box, 3 to 4 hours per PI. Interesting. Now, I've had a number of executives and others push back on that a little bit and say, 3 hours for problem solving? 3 hours for the entire program every 10 weeks to get together to deal with the endemic problems that are preventing velocity? I think that's a pretty good investment. And with that short discussion, most executives agree, and they'll open up that time in the time box and they'll start taking that IP sprint a little more seriously because now they understand how critical that time together is, right? In only 3 hours, we're going to address some issues that have prevented us from making the type of progress that we thought, or perhaps prevent us from increasing the velocity the way we would otherwise deserve. All of this is available to us if we could just eliminate that impediment in the middle. That's what we do in Inspect and Adapt. As I mentioned, a big piece of that is a PI system demo. At the end of every PI, the teams demonstrate that current state of the solution to the stakeholders. And it's a pretty exciting time because, let's say it's a pretty big art, maybe it's 10 teams. 10 teams have just worked for 10 weeks. Wow, that's 100 team weeks of investment in this process. That's a really big deal. We should see a lot of cool stuff. So I want to come to that demo. I want to see what's new and what's different from 10 weeks ago. Who's it led by? Well, just kind of observations. We see product management and product owners and sometimes the system team leading the demo. Doesn't really matter who leads it. Various people are going to participate. Individual product owners are going to want to show off their stuff. Product management might want to talk to their customers or their key stakeholders about the accomplishments of that PI. It's a pretty big deal. Pretty big celebration, really. As I mentioned, business owners and program stakeholders, RTE, Scrum Masters, and teams. Absolutely. Teams attend the demo because they're showing off their stuff. And teams need to see things too. They haven't seen, maybe they saw the system demo, maybe they didn't. Obviously, we wouldn't necessarily have 50 or 100 people together at every single system demo. So this may simply be a team member over here who first time is taking the opportunity to see the real system unfold, right before their very eyes. Part of that process is to report on the performance of the program. And in order to do that, we're going to use this funny thing, these PI objectives and this business value that we talked about, this kind of slightly odd construct. What is business value? And we're gonna measure how well we did compared to plan. Because a couple reasons. Number one, it's a commitment-based system and we want to do well. And number two, we want to learn. So we want to gain the knowledge that helps us understand how well we did. So we'll meet with the business owners, typically right there online in C2, at the same time. Sometimes this is a separate meeting, but most typically we just all show up together and we talk about what we've achieved versus what we planned. And each team then takes their plan versus actual business value, and we're going to roll that up. And that's going to create this unique measure called program predictability. Predictability is a pretty big deal in the research and development world, and we know it's very difficult to predict for, our 3-year planning, sure, or even 1-year planning, well, guess what? It's not trivial at the 10-week level, but it's easier. So with the proper constructs in place, we should be able to get pretty predictable about that. And if not, then it's going to be kind of hard to manage the process because we're not going to know whether or not these things that we've agreed to are going to occur or not. So predictability is a big deal, and that's why we call that the program predictability measure. Let's take a look at one. Let's just say here's a team, and they achieved 60% of their objectives over time. Is that bad or good? Well, I'm not really sure. What I do know is that then that went down to 30%. Wow, that really caused problems because that means that that program did not deliver in any kind of an acceptable range. So that team isn't really able to predict their outcomes even in the near term. Team B is doing a little better. Maybe it's a more stable environment. Maybe they've been together longer. Maybe they don't have quite the technical challenges that Team A has, but they operate in this band. And the net effect of that is that the program, at least at this period, was not comfortably meeting its commitments. Instead, it was operating below what we would think is this kind of acceptable range. So let's look at that range. So what is this range? This is the range that we want to operate within. You might say, well, don't we want to be 100% predictable? Well, be careful what you wish for. I actually had a phone call from a VP not too long ago who said, this one team is driving me crazy. They do 100% of what they commit to every single PI. And of course, you might wonder, well, isn't that good? No, he said, there's no variation at all. They've backed so far off of their commitments that they can assure us every single time they do everything they committed to. We're not really achieving any innovation there. We're basically kind of mining the status quo and using the predictability measure as a level of goodness where 100% isn't even the target. Now, there's an exception to that in a second, and I'll talk about that in a second. But this is where we want our program to run, right? Now, does that mean that I get 80% of the things we committed to? The answer is no, it doesn't mean that at all. And why is that? It doesn't mean that because the stretch objectives are included in the plan, but not the commitment. So consequently, you can run at 100% because you have stretch objectives that are not included. Therefore, you can occasionally go over 100%. So this 80% is not 80%, right, of the committed, it's 80% of the total. So consequently, it could easily be 100% of the committed objectives. And that gives us the predictability we need in order to be able to run the business. And that's important. What does it mean to be in an effective process control range? It means that we can handle common variations. So things go wrong in the process, and there was a problem with a widget here, and somebody had, somebody was out with a back injury during this period, but we're still operating in this highly predictable range. We deliver 80% of the total plan, and we deliver about 100% of the committed plan. But if there's a flood in Boulder, like there was almost 2 years ago now, nobody met their PI objectives during that period. People had to worry about their homes and their families. So of course not, we fell outside of that range. So that's a special variation. We can't count on special variations. If some supplier goes bankrupt in the middle of our deliverable, or something else odd happens like a flood in Boulder, we're going to be outside of that range. But barring that, if those things don't occur, we are in good shape. We can run our business in a predictable manner. And I think predictability is huge because how do you plan for the impact of this solution if you don't even know if the solution is going to be ready? You tell a bunch of people it's going to happen and you create false promises? Well, we talked about that. We know what that is. That's one of the primary sources of waste. So operating in this process control range is a pretty big deal, and we achieve that by handling this strange thing called business value, and we call that the PI predictability measure. And as an executive, when I'm speaking to other executives out there, this is a pretty big deal. And I think that teams that can do this are teams that can absolutely continue to improve their performance because they are predictable. How does this team improve their performance? Wildly? Hardly at all. How does this team improve its performance? Well, you could fully expect they're in a kind of controlled state. They do a pretty good job of estimating their work, and they will continue to do that. So that's the PI predictability measure. It's kind of an odd duck. It's not, I don't know that it's described in any other methods or frameworks out there, but it's one that we absolutely depend on. And the question I ask when I'm working with teams and programs is, how did they do? And oftentimes they'll say, well, we did pretty well. Well, what does that mean? Well, we did all of our commits and most of our stretch, and some things changed. We actually had to incorporate a few more things. Well, that's great. Didn't do all of our commits, not as good, because that meant that I've disappointed some people, I've created some waste. Well, what would we do differently about that? So this is how we improve our performance over time. The next part is the meaty part. And the first part of that is to come up with a short retro that says what kind of problems we continue to see. And we're going to systematically address these, and we're going to use a very structured process for this. And that is a problem-solving workshop. And it occurs in a series of steps. Step one is that after the retro, have we agreed on the problem to solve, okay? Why do I have this one here? Because sometimes we see that, not unusual at all, as programs improve their performance. Step number two is we're going to apply root cause analysis. We're going to try to understand what caused that. What are the various sources that contributed to the fact that we didn't have a good release? We didn't meet our commitments for that release. And we use the 5 whys techniques to do that. And for those of you who have any kind of quality training, this is what you do with root cause analysis, is say, yeah, what are the potential sources and what are the sources of the sources? And you get down to fine grain pretty soon and you go, look at all of these, right? This looks to be quite a body of work here, or quite a body of evidence that says we've got a lot of root causes that feed this one that relate to this one. So now we're getting closer and closer to the root cause. And we can then identify those. We can say, this looks like a pretty big deal, and we'll do it slightly different. We'll just have people vote. We'll say, please put a check mark by whatever your favorite root cause is. These are smart people, after all. They're the ones that have the problem, and they're the ones that are going to be addressing the solution. Let's put the check marks in there, and let's do a Pareto chart. The Pareto chart, that's the oversimplified 80-20 rule. It's not always that way. But the Pareto principle basically says in any scientific endeavor, manufacturing, research and development, or whatever, most of your problems are caused by a relatively smaller number of root causes. And we get to the root cause, these people have decided that this is a pretty big deal, and now we can take the next step. The next step is to restate that. So we just don't have that architectural runway. We did not have the ability to do fuzzy search, and we tried to implement 6 different features that needed to be dependent on fuzzy search, and we didn't get it done because we didn't have architectural runway. Okay, well, let's talk about that a little further. What are some solutions? Well, let's try capacity allocation. Let's set up for each PI now the capacity allocation that says, let's take 20%, just for the sake of argument, and let's devote that to enablers. Now, that means that there's some other features that aren't going to happen. Well, it's a zero-sum game because 100% is 100%. Okay, that's a potential solution. Let's use capacity allocation to do that. And now, okay, let's try capacity allocation. And oh, by the way, with respect to fuzzy search, we need to nail that. Let's put another enabler in place to make sure that we don't have that same problem again. So here's a technical solution to that problem that says, let's nail that technological impediment. And here's a business solution which says, let's use capacity allocation. So 2 examples of things that could come out of a brainstorming solution. And where do those backlog items go? I think you know the answer to that. They go right into the PI backlog at PI planning the next day. So I'm going to plan my PI in my 2-day envelope. I've got my backlog. These guys go right in. So in goes the let's solve that problem with fuzzy search, and in goes the let's start using capacity allocation. And now you've closed the loop. Now it's not, hey, we ran a PI and we got some feedback. We ran a PI, we got some feedback. We looked at the problems that we're addressing. We looked at the root causes, and we identified some improvement backlog items that we moved right into the backlog. Well, that's a pretty tidy closed loop system, because this program, I guarantee you, if they run inspect and adapt every PI, 6, 8, 10 weeks, whatever, I guarantee you, it's the only guarantee you'll get out of this class, that if your programs do that inspect and adapt, they will improve. Obviously, something I feel very strongly about.